In order to algebraically test to determine whether a function is even, odd, or neither, we'll simply plug negative x into that function and then analyze what the result is. If we get the exact same function that we started with, then we say that that function is even. If we get the exact opposite of the original function that we started with, then we would say that that function is odd. So in this example, we have h of x is equal to 2x divided by x squared plus 4, and if we want to determine whether or not it's even or odd, or perhaps neither one of those, what we'll do is plug negative x into the function. Now, anytime that we plug something in for the variable, I recommend that you open up variable holes, and this will help to keep our signs correct, and then we'll plug negative x into both of those independent variable spots. And now we simply evaluate or simplify this. In the numerator we have negative 2x, and in the denominator we have both the negative and the x are being squared, so this quantity becomes positive x squared plus 4 in the denominator. Now we can tell right away that when we plug negative x into the function, it's not the same as the original function, because of this negative sign up here. But now we need to determine whether or not what we have is actually equal to the opposite of the original. So let's take a close look at what the opposite of the original function would look like. The opposite of the original is going to be the opposite of the original function, which in this case was 2x over x squared plus 4. So let's copy paste this left-hand side, and when we have this negative on the outside here, essentially that negative can be multiplied into the numerator or in the denominator, certainly not in both. But if we put it in the numerator, it makes it easier to notice that what we have here, the opposite of the original, is actually the same thing that we got when we plugged negative x into the function itself. So let's say then, since the function evaluated at negative x did turn out to be the opposite of the original, therefore the original function must have been odd. Let's look at one more example. Again, to determine whether or not a function is even or odd, we're going to plug negative x into the function and then analyze what we get once that's simplified. So the function g evaluated at negative x, we'll start by just rewriting the original function with a hole for that independent variable. It makes it easier to get our signs correct when we plug that negative x into that independent variable spot. Let's copy paste the left-hand side and then simplify the right. This negative has to just stay put for a moment while we square that quantity, negative x. So again, this negative is just copy pasted down, and then negative x quantity squared, that is positive x squared and then plus 4. Now, let's notice that once we plugged negative x into the original function, we actually did get the exact same function that we started with. And we'll say, therefore, then the original function that we started with must have been even. And by the way, when we have an even function, we can expect to have symmetry about the y-axis. And if we pop back up to this first example, we could also say here that we expect to have symmetry about the origin. Pop over here to desmos.com really quickly to check both of those answers. In part A, we had h of x, which is the same thing as y, is equal to 2x divided by x squared plus 4. And we can see that we do have symmetry about the origin, meaning essentially that if this graph were to be turned upside down, we would see the same thing. And in part B, we had g of x was equal to the square root of negative x squared plus 4, and we see that this does give us the graph of a function that has symmetry about the y-axis. So we can plug these functions into our calculators and look at the graphs to verify that our answers are correct.